Okay, take a look at Chapter 6, which is on the open-closed principle. This is kind of a strange concept, having something both open and closed. So let's look at it a couple different ways. Um, what we want is we want sometimes we have code that we just don't want to modify anymore. It might already be all tested. It might be some already saved into a DLL or a library of some sort, and so we don't want to recompile it. So it might be closed for modification, but we still want to be able to add things to it, and so we say it's like open for extension. So that's what the saying here. Software entities should be open to extension but closed for modification in some ways. Um, it talks about some other things that we can do, bug fixes to software and things like that. But one thing that we're going to talk a little bit about is this client awareness. Um, Closed for modification generally means that software that's using this class shouldn't have to change to make changes to the class itself. So sometimes this open-closed principle kind of is applied more there, saying that the software that calls or uses these classes shouldn't have to modify, just internal modifications are allowed. Also introduce this idea of software that's tightly coupled and loosely coupled. Generally, we want software we, that works closely together, like one or two or three classes or objects. We want those generally tightly coupled. Often they have to be calling on each other and using each other a lot. But we also want sections of software to be loosely coupled. So we might have this assembly and this assembly. And we want to have limited interfaces between those two. So there's often this kind of pull between tightly coupled and loosely coupled software. So we're going to look at extension points, ways to modify software without actually changing it in some ways. Without extension points, you might have a client, some main program or something that'll use, like in this case, our trade processor program. But if we update our trade processor program to this trade processing version 2, say we change how this is called, how we use the different methods in it, then our client here also has to change how it uses this. So we're going to try to look at some ways of modifying trade processor where the client doesn't have to change. And that gets back to this client awareness principle. We're going to look at three different methods: virtual methods, abstract methods, and interfaces. You're going to do work more on interfaces in the assignment. We're going to go through these two earlier ones first. Virtual methods now. I don't know if you're familiar with virtual and abstract methods. So let's kind of review those. Virtual methods are methods that can be overwritten by a child, but there is a method there. So we'll have here's our client and here's our trade processor, and we'll have a process trades method here. This will be a method that's defined and uses things, but it'll be set up as virtual. And then we'll have this trade processor 2. We'll create this, and it'll be a child of this. And it'll override this process trades method. So here in the trade processor client, where it's used to calling process trades here, it'll call process trades in a version 2 of this. Often this process trades will call this process trade, so incorporate some of this material. So it's kind of like a decorator. We're adding features onto this process trades, but we're using a child, not going through an interface here. I don't find this all that useful of a description, so I've put it into code also so you can see it. So let's look at this virtual trader. It's in the attached program. So we've got this trade processor, and it's the old trade processor we've been looking at for weeks, that parses trades and stores the trades in a database and stuff like that. And the one public routine is called process trades. It reads the data, parses the data, and stores the data in a database. So we've seen this before. This is all set up, but this is the only public method in here. And so our main program creates one of these trade processors, calls it parse trade, and then calls process trades there in that method. Now we're going to make a new version of this, process trades version 2. And it's going to inherit from process trades. So it's going to be based on process trades, and it's going to have its own process trades routine here. And what it's going to do is do some more things. In this case, it's just going to log, say we're doing more things. But it also is going to call the base parent's process trades. We say base dot process trades to call the parent's class. So again, we created this. It's inheriting. It's a child of this object. And then it does some stuff in its process trades, but it can call the parent's process trades also. Now, let's talk a little bit about virtual. And so this method is defined as virtual, and this method is overriding this. Now let's kind of see what that means. So in our main program here, we had this process trades. We're going to declare a new one here. So we're going to create a trade processor version 2. And now we can run this. So it will go through, process our trades, but it'll also add these features to it. So it calls process trades here in the version 2 here, and it says just logs this using version 2, so we know it's using that. So it prints that out, and then it goes to the rest of the parent class and simulates the database connection and processes the 4 trades and stuff like that. So this is the old process trade stuff. In fact, if we look at this go back in the main program here and just did it with the old one, it is just going to do those last 2 lines. Again, simulating the database connection and processing the 4 trades. So again, we've had to create this process trades version 2. Now you might say we don't want our client to know the changes there, but and we're having to do a new with a different object here, and that kind of violates that client awareness principle. But we're going to kind of ignore this the object creation stuff, because in larger programs, you generally are not going to do very many new objects. You'd often be passed in this object, or use a factory to go get this object or something like that. So what we're really going to focus on as client awareness is this code below this line. Nothing below this line is going to change the methods we'd call. And again, right now we're just calling one method, but often we'd have a bunch of logic and a longer program calling multiple methods here, and this is what's not going to change. So we can switch from trade processor to trade processor 2 without changing any of the actual code itself that calls it, because both of them implement this process trades method here. Now let's look a little bit at virtual. Now to see virtual, we've got to get rid of the textbook defines this as a var trade processor. Just a var generic variable, and we're going to actually change this. Let's change this to a trade processor. So we're going to define this variable as the parent class. So the variable here. So the variable is still going to be one of these trade processor classes, and that's why we use inheritance, because it's the same type. So this can play the role of one of those. And then we're going to call it. Now let's say we didn't have the virtual in here, and we didn't have the override in here. Now when we run this, it's not going to run the new method. It's just going to run the old method. The idea here is although we created a trade processor version 2, we are saying, classifying it as a trade processor. So when we call this process trades, trade processor, process trade, it goes to the parent object, because that's what it thinks it is here. It thinks it's a parent object, and does this process trades. And so it doesn't print out the in version 2. It actually thinks it's in version 1. And that's why we need to do the virtual. Adding the virtual in here says that this is likely to be, this may be overwritten in the child, and if so, use that version. And so in our trial version, we have to do, to overcome that override, we put in a override here. So public override void trade process. Now, if we do this, even though we are saying that this is a trade processor object, it's going to call the process trades in this version 2.1. So now it'll see that we're using the version 2.1 here. Okay, so having that will let us create a child class, have it pretend to be a trade processor, and still call this new version over here. So again, we can have a variable that's the old variable type. We can just pass in or give it a new version of it, and then the rest of the code will be the same. Okay, so that's this virtual methods where process. Now there's some limitations for this. Generally, we're still calling the old trade processor, maybe just adding some functionality to it, but we're actually just calling it as one chunk and maybe doing some stuff before or afterwards often. So there are some limitations to sometimes how you can do this and what you can do. You can move the code here and redo it all. So there are some options there, but a better way often to do this is with abstract methods. So with abstract methods, we're going to have our client, our main program here, and we're going to have a abstract class, a class that has a number of abstract methods. And here, rather, the public method is going to be set in here and do things, and it's going to call these 3 abstract methods. Now, abstract methods here are not going to be defined here. We're just going to have empty signatures for those methods here, and then we're going to have those implemented down here. And then now if we make a new version of this, let's say trade processor 2, we can redefine these different methods in different ways and now use these here. So let's look at how that looks in code. So I'm going to close the virtual trader and that. And now I'm going to go to the abstract trader and look at that. So again, we have our main program. We create a trade processor version 1 here, because again, right away we've got I'm calling this trade processor version 1 and trade processor version 2, and I'm calling this abstract thing just trade processor. So we're creating a trade processor version 1 and calling process trades there. So let's look at trade processor. This is the abstract class. It's labeled abstract, and a bunch of these methods are abstract. Parse trades, again, and these are empty methods there, just have a semicolon at the end. They don't have any code in them. Now we do have some methods here, log messages here, so we can, in a abstract class, we can have some methods. Store trades is a abstract method, and process trades calls these methods. It calls read trade, parse trades, and store trades, and these are all the abstract methods above here. Okay, so that's what we have here. We've got this trade processor, we have process trades here, we also have log errors here. And then we have got 3 abstract methods in that class. Now here we're going to, in our trade process, we're going to inherit from here and define those methods. So in trade processor version 1, it inherits from, it's a child class, a trade processor. And so it overrides and defines the read trade data, the parse trades, and the, it has a couple other fields in here. It has process trades in here, and this shouldn't be here. I'm going to delete that. See if I can remember to do that in the version that you download. Okay, so and then store trades is there. So again, it has to implement all the abstract methods. This has a number of these abstract methods: store trades, read trade data, parse trades, and this has to implement all those. So it implements all those abstract methods. So this should work fine. We can call this main version and store it. In fact, while this is a var, we could actually declare this as a trade processor variable. So we can declare it as the parent, the abstract type, and pass it in here, and everything works fine. So Now this should be printing out version 2. Let me figure out that error. Okay, and what I noticed is that it's still running this virtual trade. There's can only be one startup project. So if I want to run this abstract trader, I'm going to right click on that and set that as a startup. And so now it should run this abstract trader. You can notice it's bold now. So now I'll run that. And again, it should be doing version 1 of all these classes. So it's running this version 1 of each of these classes. Because again, we created a version 1 object in the main program. We created a version 1. So we could just as well create a version 2 here instead of a version 1. And run this, and it should run the same. Version 2 implements the same abstract method, just in a new updated version of it, and prints them all out. So again, version 2 here implements the stored trade method, the parse trades, the retrade data. So updated versions of those methods. Now it's interesting that neither version 1 or version 2 implements the process trades. This is kind of the little algorithm that grabs, sends a stream to this method and gets a set of lines, sends those lines to parse trades and gets the trades back and sets those trades to be stored in the database. So that's is done always in this abstract class, but these sub methods are each abstract and can be redefined in these different methods here. And again, we wouldn't necessarily have to use them all, change them all, but we are. Well, I guess we can just duplicate them if we want from version 1 to version 2. Now in our main program, again, nothing below this line has to change when we're going from version 1 to version 2. And in fact, our variable doesn't have to change. All that's changing is what we're calling here. And again, we could be using a factory to go out and get one of these trade processors. We could have been passed in one of these trade processors. It wouldn't matter. We can still store it in the same variable type and use it in the same ways in here. So that's why they're saying that you may not have to have change the client to get this to work. Although in our version, the way it's set up, we do have to have this slight change in the client to get this to implement one or the other. Okay, so that's abstract methods here. And again, we had an abstract method, and then we implemented two versions of this that implemented the abstract methods. And again, in the abstract methods, we can have code up here like process trades and log methods, but we can have empty signatures of methods that force them to be redefined down here for some of these methods. Okay, that leads us into another way, is that's the interface way. And we could, rather than having an abstract class here, we could just define an interface here and have it just create an interface, and then have different objects implement that interface. And this is what I want you to do as your assignment. I want you to take this abstract trader and change it so that process trades version 1 and process trades version 2 implement an interface, not an abstract class. So here, this abstract class, we want to change that to an interface. So not an abstract class, but an interface. And then we want you to modify this in different ways. So again, some things, interfaces can't have methods in it. So like this method's got to be moved into each of these methods, and this method has to be moved in each of these methods. And we actually are only going to define, we're not going to define any of these. We're just going to define the public methods in the interface. Interfaces usually only do signatures of public methods, and the only one there is the trade process, a process trades method. So as shown in here, so this process trades is going to be the only method defined in the interface, and then both of these are going to implement that process trades and then the other methods here. Again, and you don't have to do, we're not going to do the special audit way. That just shows a different way of setting this up. You can use the same code here. So you just want version 2 to implement that and version 1 implement that. The assignment shows you a little bit more about that. it talks about, again, moving that log message over into process trades version 1 and process trades version 2, moving process trades into both, and then changing and renaming it process trades for an interface. And again, the interface should only define this one method. And then you'll have to do some work with removing some of the virtuals and abstracts and overrides that are around in that class. And again, you can do that to this abstract trader class here. Okay, so that's this method. So that's basically all there is in this chapter. It's really short chapter. It does here talk a little bit about this Goldilocks zone of, not having too much adaptability and having some. I've certainly seen that before. Certainly some looked at code that's not very adaptable at all, but I've also looked at code that they've made it so adaptable it's just overly complex. Right now we're working with a robotics system, and I can understand it has a file of settings, an XML file of settings that you can have, and so you can set that up and do some settings without recompiling or doing stuff to the code. That's really good. But in this program, for this robot, not only has one file of settings, that file includes other files of settings, and that file includes other files of settings. So I have this whole list of about 20 include files or setting files that are all linked together in different ways, and it's really nice and adaptable, but it's just so confusing. It almost makes it impossible to use. So again, that's going a little bit too far on the adaptable scale. So remember that we want to make the code adaptable but not too adaptable, or extendable but not too complicated. And that brings us to the last thing this week. You'll have to do these questions. Just write about a paragraph answers to each of these questions from that chapter.